All right. Tricks to try. So these tricks to try are in no particular order. You're not going to ever use all of them. You're not going to use them in this particular order. It's just you're going to have to look around and see what it is you can use for the particular problem you are on. First one. We've done this already last week, so please write it down. Change everything to sine x and cosine x. Or sine theta, cosine theta, or sine 12 degrees and cosine 12 degrees, whatever it may be. All right, step 2, or not step 2, trick 2, substitute a Pythagorean identity. Substitute a Pythagorean identity. Those are the ones that we learned. I'm going to flip it really quick. These 3 here. Or the rearranged. These up here are the rewrite as sine and cosine, the reciprocal identities. All right. Trick number 3. Distribute. Now that distribute may be a single distribution, a double distribution. What do you guys typically call double distribution?
Not fun.
Not fun. It does start with an F.
Oh,
foil. Foil. Or foil. If it's a double distribution, you can call it double distribution. You can call it foil. For the opposite direction of distributing or foiling is factor. Trick 5, get or rewrite with a common denominator. Whew. 6, almost done. Clear complex fractions. Remember that whole unit we spent beginning of the school year that you guys did not like and wanted to drop the class? All done for a reason, to prepare us for this kind of stuff. No. There's not a lot of them, but they come up every now and then. Factoring, clearing complex fractions, solving fractional equations. All right, clear complex fractions. And the last one we are not using today, but it is a trick we will use. Multiply by the conjugate. All right, again, 7 we're not going to use today, but we will eventually, and it comes up on the test, and I'll tell you right now, it's probably one of the most missed on the test. Kids just forget that conjugate is one of the tricks to try. Do you guys remember working with conjugates last year?
Yeah, I remember the ugly word.
You remember the ugly word. You don't remember what it was? I'm trying to think of how you would have had it.
Once you say it, I'm going to remember it.
And then you multiply top and bottom by like 2 plus
like
root 3.
Yes.
Do you guys remember that?
Yeah.
No?
Yes.
Oh, I see.
And then you would have foiled? No? Maybe?
Yeah, but I don't remember it being close.
Or you guys did, or something like this.
Isn't that to cancel off the roots?
Yes.
Yeah.
Oh,
Vaguely remember?
Definitely darn.
Yes?
a little bit.
Yeah. All right. That's conjugate. That we won't not do today, but we will be doing soon enough. All right. Simplify. We're going straight into examples. Number 1. Secant theta minus sine theta times tan theta. All right. That is a minus sign. Okay, thoughts? What to do? What to do? Anyone?
You tell me.
Well, we have 7 tricks, 6 because we're not using the number 7. What was that? Perfect. All right, and he wasn't even here on Friday. He said take secant and change it to secant equal cosine or 1 over cosine. Take away sine theta Now I'm going to take his advice and do the same thing with the tangent. What does tangent change to? Sine theta over cosine theta. Do we agree?
Yeah.
Okay, now this here is just multiplication. So I have 1 over cos sine theta. Take away what sine, because with multiplying, we don't need a common denominator, we just multiply. What sine times sine? Sine squared over, or sine squared theta over what? Over cosine theta. What's nice about these two fractions? They have a common denominator. Can I rewrite it as one fraction? Yes, yes we can. 1 minus sine squared theta over cosine. Cosine squared or just cosine? Just cosine. I am going to have you finish it because this is just like what you had on Friday night's homework, and I just did some of these with you when I went over homework questions. I'll give you. I'm listening. This is in your rearrange section, or could be in your rearrange section if you added it. All right. Johanna, can you tell me what to do next? No, you're not sure. Do you remember what 1 minus sine squared? I'll give you, it's right here. Rearrange it in your head. If you get 1 and you move your sine squared over, would it be 1 minus sine squared? What would you be left? Good. So cosine squared theta over cosine theta, does that reduce? Cosine theta is gone and cosine squared becomes cosine theta. What's the final answer? Cosine theta. Boom. Got it? Yes. All right, number 2. Secant squared theta minus 1 over secant squared theta. There is more than one way to approach this. So I'm going to give you guys just a few seconds to think. What would you do? If this was a test question, what would you do? 1, you wouldn't be on your phone, so put those away. Very good question. And I meant to bring that up with my morning class. Why can I not reduce this? It's the minus 1. If you have binomials or trinomials, you can't reduce just pieces.
Yeah, well, because there's binomial.
Good, good. Do you guys hear her? Yes, so you cannot reduce. But there's other things we can do. So any thoughts? Heads up off the desk? Yes.
So for the secant, there's a minus 1 equaling that, like, for your rearrange, where it's
All right. Yes? Okay, she said rearrange and change that. Anybody else have a different way that they would have tried it? Darren, were same way, or were you going to do something different?
I would do something.
Louder? Okay. All right. I just want to show you this really quick, and just to let you know, this is, I would not suggest it on this problem. The method that both of you guys gave me is perfect. I'm going to use it, but this is a method that, or a trick to try that we could use in other problems, that we will use on other problems. Breaking fractions apart, it's something we do a lot in this class. So secant squared theta over secant squared theta minus 1 over what? Do you agree if I'm breaking them up, they have to have a common denominator? Right? Because if I had this, would these two things be the same thing? Yes or no?
Yes.
All right, so again, you could do this method. It would work out perfectly fine, but I'm going to continue with the way you guys gave me. This is just a heads up. It is a method we do use and we will use eventually. I just want to make sure you understand how to split up an adding or subtracting fraction. Got it? All right, so what did you guys say secant squared theta minus 1 becomes? Tangent squared theta over secant squared theta. Any suggestions from here? Yes, Meg?
Secant is 1 over cosine.
Okay, 1 over cosine squared. She said for the secant squared. Keep going.
Tangent is sine squared theta over cosine squared theta.
Perfect. All right, who can give us the next step? She said rewrite and rewrite. That was the trick number 1 over with sine and cosine. Who can give us the next step? Yes. Multiply by the reciprocal. Good job. So sine squared theta over cosine squared theta times, Kellen, put those away and focus. All right, times, he said the reciprocal, so what would it be? Over 1. And does anything reduce? Cosine squared theta, and that leaves me with what? Sine squared theta. Good. Questions?
How many more practice questions?
10 more.
Is the other method like the same?
The one I showed earlier. I will tell you this. Sometimes some methods are easier than others. Sometimes they work out the same. So let's just do this one really quick. What's secant squared over secant squared? What is 1 over secant squared? 1 over secant squared is?
Oh, it's the cosine.
It's cosine, right?
Yeah.
1 over secant is cosine. And what's 1 minus cosine squared? Oh, did it work out the same?
Yes.
Now, did any of you look at like, oh my goodness, that's so much easier?
Yeah.
Yeah. So most kids think of that way because that's like really the trick we've been using. But just keep in mind, this is a trick that not only worked out really nice here, but it is a trick that we will be using quite often in this class. All right. Did it make sense? All right. One, two, and this would have been 1, 2, 3, and then 4. Not to say that one way is better than the other. I am just letting you know that there are some people that will get it done in 3 steps and some that'll take 4 to 5 steps. It just depends on which method you use. And there's not always one that is the only right way. As you can see, there's multiple ways. All right, number 3. Sine theta, cosine theta, and then tan theta plus cotan theta. Think about it. I'll give you a few seconds. All right, suggestions? Actually, I'm going to call on Allison. It's already in factored form, so maybe do what instead? Distribute. Anyone else? That's a good. It's a good trick to try. Anyone else? Yes.
Try to add the tangent and cotangent.
Like find a common denominator. That is another trick to try. So we're going to decide which one we want to do, and you can try one if I try another. One comment was to distribute. This is a single term. Do you guys see that that is a single term? Distribute this single term to the tangent and to the cotangent. And the other one was, I'll be right there, is change tangent to sine over cosine plus cosine theta over sine theta. Oh, really quick question. He said rewrite these with the common denominator, correct? Try adding them, you said?
Yeah.
Okay. Question I have is, can I cross reduce these? I get that question every year.
No, it's addition.
No, because it's addition. Good job. I could if this was what? Multiplication. Addition, you're not allowed. Correct. What was that?
It was a nice problem.
Okay. All right.
Would you add the first one?
Okay. Well, that's up to you. That's what I'm saying. Do you want to find a common denominator and see what this comes up to, or do you want? Now, if I were to distribute, should I change it and then distribute and then have things reduce?
Yeah.
All right, so I will leave it up to you. You decide which method you want to use. Change like this and distribute, or change like this, don't distribute, and find a common denominator. You decide which method you like. Distribute? Are you guys okay if I distribute? If any of you want to try it the other way, try it and see what you end up with. All right. No. Sine theta, cosine theta. And then what did we say tangent was? Over cosine theta plus. All right. And then we distribute. Now, I'm not going to go too fast and like reduce in my head. I'm going to go a little slow. Sine theta times sine theta is sine squared theta, and then cosine theta stays cosine because there's no cosine here to make it squared. Do you see that? This is all over 1, and 1 times cosine is just cosine. All right, here sine theta times nothing is just sine theta, and then cosine theta times cosine theta is cosine squared theta. All over 1 times sine theta is sine theta. Now, I do not have to find a common denominator because not in this step anyway, because what's going to happen here and here? Reduce, reduce, reduce. So I'm left with sine squared plus what? Sine squared theta plus cosine squared theta, which equals 1. Did any of you do it the other way? Did it work?
Yeah.
Yes? Can we put your work up here to take a look at it? Do you mind? You did a lot of it in your head?
Yeah.
All right. Thank you. Yes, he did do a lot in his head. All right. So you put sine over cos and then cos over sine, and then you multiplied this by sine and got sine squared, and multiplied this by cosine and got cosine squared, and said it was 1 over sine cos. We did end up with 1, and you ended up with something a little different.
Oh, I just
Okay, so it's right here. So this would be 1. Can I write on here for you?
Yeah.
This would be 1 over sine theta cosine theta. Do you see that? Sine squared plus cosine squared is 1. And then your common denominator you set up was sine theta cosine theta.
Yeah, I just like forgot about that.
And you just crossed it all out?
Yeah.
Okay, and then gone, and then your answer is 1. All right, thank you. So it does work. So there are multiple ways, as you can see. You're going to find out what works best. Thank you for sharing. All right, number...
Wait, Ms. Torres, how did you get the denominator? So when you distribute, the denominator stays the same? That's in the parentheses?
Whenever you're multiplying fractions, you just multiply top, multiply the bottom. So that times that is this. 1 times cos is cos. Sine cos times cos is sine cos squared. And the 1 times sine is sine. So you just multiply the numerators, multiply denominators. Numerators, denominators. Yeah. All right, number 4. Tan theta plus cotangent theta all over cosecant squared theta. All right. As with the last, there are multiple ways to do this. The way I'm going to show you is a method you need for the test. Now, it's not the only way to do this problem, but it is a method you need to know for the test. Are you ready? Okay. I want to just get from you first, this first step, what would you think to do? Make them into, oh, like split the fraction? We can do that. Yes. Anything else? Okay, change everything into sine and cosine. All right, that's what I'm going to do. So tangent is sine theta over cosine theta plus cosine theta over sine theta. Oh, can I cross reduce those? No, because of the plus sign. And then 1 over what? Sine squared theta. Alrighty. Now, there are multiple ways. one way is, I'm going to cover this down here. Do what Darren said and find a common denominator, rewrite the fraction, and then once you get that to one fraction, multiply by the reciprocal. All right, perfectly fine, but I just want to show you this way, and I'll show you another way after this one. I want to show you this way because it is a method you need to know. Remember when I made a reference earlier back to the Unit 1 in the school year, the very first unit, the complex fractions? If you look back at your tricks, number 6 is clear complex fractions. Do you guys remember from Unit 1, or even from last year is where you initially learned it? How do you clear a complex fraction? Perfect. She said multiply by everything by the common denominator. Cosine, sine, sine squared. What's my common denominator? Sine squared theta with a cosine, so that one reduces. Sine squared theta with the cosine theta, and sine squared theta with a cosine theta.
So right here we're just finding GCF.
Common denominator. Yeah, so this is Unit 1 all over again, just with trig functions. All right, what reduces on this first one here? Cosine theta. What reduces here? One of the sines. Sine is gone and sine squared becomes sine. All right, and what reduces here? All right, in the numerator, what do I have here? Sine squared or sine cubed? Sine cubed theta plus, let's see, the sines, one of the sines reduced, and I'm left with cosine squared what? Is there a sine left as well?
Yeah, there's a sign.
There is a sine, okay, all over what? Cosine theta. All right, I'm going to stop here, and I'm going to let you guys do the next 2 to 3 steps. And I will give you a hint in the numerator. There is something you can do. It was one of our steps, step 4 or trick 4. What was trick 4? Factor the GCF. I'm going to have you finish that. GCF, reduce, if possible. If not, see what else you can do. Identities. Oh, excuse me. What is your GCF? What's left when you take out the sine theta? Mm-hmm. Good. Sine squared theta plus cosine squared theta. Do you guys agree with her? That would be sine cubed here and then cosine squared sine. Yes or no? Nothing reduces, but what do we know about sine squared plus cosine squared? Is an identity? Yes, so what does it equal? 1. So sine theta times 1 is just sine theta over cosine theta, which we do not leave. What do we rewrite that as? Tan theta. Anybody feel no way? No? I know when I did this with my morning class, they were like, oh, there's no way I would know to do that, da-da-da-da-da, and I had a few kids just say, what about this and what about that? So I want to bring up just really quick what one student suggested. She said, if I wanted, could I have done this? And I want to bring it up because it's a really good thing to think, like, what else can I do? Because there's not always just one right method. Okay. She said, could I multiply by the reciprocal and call this, leave the top as is, sine theta over cosine theta plus cosine theta over sine theta times, what's the reciprocal? I'm going to put in the front, sine squared theta over 1. And then she said, can we distribute like we did over on this one here? Sure. There's nothing wrong with that. There are a number of ways you can do this. I just wanted to show you this way because this is a tool you need for what? The test. All right. Questions before we move on to number 5? All right. Sine theta over tan theta. Take away tan theta over secant theta. Can the tangents produce? No. All right, thoughts on what to do?
So, the suntan at the beach was,
Suntan at the beach, I like it. Unfortunately, can't use it on this problem. Diddly darn. All right, thoughts, anyone? Yes.
You can work out what tangent is on top and bottom and what secant is, and you can just kind of simplify all that.
All right, so you're saying trick number 1, change everything to sine and cosine. All right, so sine stays sine. I'm going to go to make it over 1 so I can see my fraction within the fraction. And she said change tangent to its sine and cosine form, which is what over what? Good. Sine theta over cosine theta. Simplify or keep writing and simplify later? Keep writing. All right, fraction, fraction. Tangent is, again, sine over cosine. And secant is 1 over cosine. All right, and then she said, and then clean up and simplify as you go. So I'm going to do kind of left half, right half. Josh, can you tell me what I'm going to do on this side here?
Flip it, so it's sine over 1 times cosine theta over sine theta.
Perfect. All right, so he said flip it, multiply by the reciprocal. Do you guys agree with him? This is exactly what he said, sine theta over 1 times cosine theta over sine theta. All right, I'm going to go ahead and clean that one up first. What reduces?
Sines.
And what does that leave you with? Cosine theta. All right, take away. And can we use Josh's suggestion again and do this one? Same way. Yep, okay, so sine theta, I'm following what he said, over cosine theta times cos over 1 or 1 over cos? Cos over 1. And does this one reduce as well?
Yes.
And that leaves me with what? All right, tricky, tricky, because that's it. There is no further you can go. Now, kids, there's maybe 3 to 4 on homework like this. Everything else comes out as 1 or tangent or cosine or -1 or negative cosecant. Very rarely does this happen. It happens every now and then. There's maybe, what did I say, around 3-ish on the homework tonight. Now, I often get this. Is this equivalent to 1? There's 2 reasons that this cannot be 1. Can anybody give me any of them? Yes.
Because cosine plus sine.
It has to be plus is one of them, correct?
And it has to be
And it has to be squared. If these were both squared, would it work? No, because it can't be minus. It's not sine squared minus cosine squared, and there's no way to rearrange it to make it minus. All right, so it has to be squared and plus, neither of which is going on here, so this is as far as you can go. Yes?
From the fraction of there to those of there.
From these to these?
Yeah.
Okay, Josh, can you answer that? She said, how did you get from, like, say, here to here?
I flipped cosine and sine, so it's like sine theta over 1 times cosine.
Multiply by the reciprocal. Multiply by the reciprocal. Make sense?
Yeah.